human need to explore is deep within all of us. Our ancestors crossed mountain ranges, sailed open oceans to map new lands, and sought out the unknown while always looking to the stars. We're curious, and now we're at a place where we can pioneer new horizons. Because Earth, this blue planet, and all its beauty, is just our starting place.
It's time to
5, 4, command engine start, 2, 1.
Oh yeah, look at her go!
5,000 feet and climbing.
Yes, guys, we're doing it!
Now is the time to open the promise of space to all and lay the way for generations to come. When our descendants look to the stars, perhaps from a rocky moon or colonies floating in open space, they'll remember this time. When they reflect on where it started, they'll remember this place. And when they honor those first explorers who said, "Let's go," they'll remember these bold steps. We are of blue origin, and this is just the beginning.
Good morning, everyone, and welcome to New Shepard's 24th mission. Thanks for tuning in. I'm Erica Wagner, joined today by Eddie Safert. Hey, Eddie.
Howdy, Erica. I'm thrilled to join you today.
It is great to be back on the desk this morning to follow the action down in West Texas, where our launch team is preparing New Shepard for flight.
We've got an exciting day in store. Here's the mission patch. Another great rendition of the New Shepard vehicle, mock diamonds in the plume and all. This mission is dedicated to our payloads. 33 research payloads on board today, along with 38,000 postcards flying on behalf of Blue Origin's STEAM nonprofit, that science, technology, engineering, art, and math-focused group called Club for the Future. No humans on board today.
The majority of today's manifest is comprised of payloads from schools, laboratories, and STEAM organizations. Most have been developed in collaboration with NASA, many testing important technologies for our future of living and working in space for the benefit of Earth. Thank you to NASA for funding such important work and for your unwavering commitment to advancing what's possible in space. We are all benefiting.
Erica, including today's manifest, more than 150 commercial payloads from more than 7 different countries have flown to space and back safely on New Shepard.
Absolutely, Eddie. I mean, New Shepard is really an ideal platform for research. Payloads can fly inside the crew capsule, mounted to the booster for exposure to the space environment. They experience several minutes of microgravity and altitudes up above the Kármán line. And then they get to gently return to Earth, getting back to the researchers on the same day that they launched.
That's right, Erica. Certainly, I think that's key. Quick access to the data, to their payloads on the same day of launch allows researchers to collect that data, tune their system, make changes, and mitigate risk for more expensive and much longer exploration missions down the road.
We have many interesting experiments on board today, including one from Infinity Fuel Cell, and this one's called the AMPS experiment. AMPS will demonstrate the operation of hydrogen fuel cell technology in microgravity.
This company is collaborating with NASA's Johnson Space Center in Houston to develop a flexible power product. They're utilizing new manufacturing methods to reduce cost and improve reliability of fuel cells. Now, reliable power on the lunar surface is key to that future sustainable development. Lunar rovers and surface equipment habitats will all need access to reliable power.
Yeah, absolutely. And Eddie, and so excited to get back to the moon. In fact, today in 1972, Apollo 17 returned to the moon, the last time humans were setting foot on our nearest neighbor.
Yeah, well, we're excited to get back, as you mentioned, this time to stay.
Absolutely. Another interesting payload on board today is called FORGE, the Fluidic Operations in Reduced Gravity Experiment. FORGE was developed by NASA's Jet Propulsion Laboratory and will demonstrate how water and gas move together in microgravity. Future applications of this technology are important for things like monitoring water quality for astronauts in space, searching for signs of life beyond Earth. It really is a fantastic time to be focused on fluid physics using the tools of microgravity.
And a lot of experiments today focused on fluid physics. In fact, it's what inspired the water droplet shape of the NS-24 mission patch we're excited about. And we'll highlight a few of those payloads in just a bit. In the meantime, we'd like to talk about safety, which is and always will be our highest value. New Shepard was built as a human-capable vehicle from the beginning. We've spent as much time developing the safety elements of New Shepard as we did all of the other elements combined.
The New Shepard program has completed 6 astronaut missions, safely flying 31 people above the Kármán line, the internationally recognized boundary of space, including 7 women. Soon, we hope to extend that laboratory of space by helping researchers fly with their own payloads on board New Shepard. Now, I don't know about you, Eddie, but I would go in a heartbeat.
Oh, count me in. Absolutely. A chance to combine experience, space, and conduct meaningful research is a wonderful opportunity. And if you're interested in any of these opportunities to purchase your ride to space on New Shepard, with or without research, go to blueorigin.com and click on the button Fly to Space.
Today's flight has a number of payloads on board from schools, introducing students as young as elementary school to STEAM skills like coding and testing, CAD design, skills that are often not taught until college but are absolutely critical for today's workforce.
Here's one of those, Spring into Space. It was developed by elementary school students at PS 185 in Brooklyn, New York. The experiment will test how changes in acceleration impact the length of a weight-loaded spring. This initiative is led by Dr. Todd Smith at the Johns Hopkins University Applied Physics Lab, and the overall goal here is to establish a mini space program to inspire young students' excitement in STEAM fields. In Dr. Smith's words, this project has really energized the entire elementary school.
Yeah, Brooklyn's here. Welcome to the Bears. Glad to have you, PS 185. Inspiring the next generation is really an important step to achieving our vision of millions of people someday living and working in space for the benefit of Earth. It's also why we founded our STEAM-focused nonprofit, Club for the Future, whose mission is to inspire and mobilize future generations around the world to pursue careers in STEAM fields.
And one way Club does this is by taking student-created postcards to space and back. Today's mission is carrying 38,000 such postcards, giving students tangible access to space on Blue Origin's rockets. Each postcard is returned to its creator stamped, flown in space. Now, I don't know about you, Erica. It wasn't until I joined Blue that I had the opportunity to make something that goes to space, and now students all over the world have that opportunity.
That's absolutely fantastic, really bringing that to life, helping students to see themselves in the future of space. As the program grows, we are finding new ways to engage, and case in point, we're now offering digital postcards to send to space from any device. You can start by visiting the app online where you can draw or create your message and hit submit. We'll send it to space on a dedicated hard drive flown on New Shepard. And once it's safely back on Earth, you'll receive an email with instructions to access your flown to space digital postcard.
Excellent, and tons of curriculum online as well. All right, if you're just joining us, we're at T-minus 12 minutes until New Shepard flies its 24th mission to space and back. Let's talk about our mission. I know it's what gets me excited to come to work every day. Here at Blue Origin, we are building a future where millions of humans will someday live and work in space. This will enable the migration of heavy industry off our planet to ultimately restore Earth, our Blue Origin. To enable this mission, one of the first steps, or gates, is radically reducing the cost of access to space through reusable vehicles. New Shepard, for example, is currently designed for 25 missions, and we're striving to quadruple that over time. This will allow us to learn how to reuse rockets and apply those lessons learned to New Glenn, for example.
That's right, Eddie. Another gate that's super important is learning to harness the vast resources of space to create a dynamic future and help preserve the Earth. This is how Blue Origin's Space Resources team is working to make long-term human presence on the moon viable.
The thing that we're doing in the Space Resources Program is really learning how to live off the land in space without bringing everything from the Earth. And we've managed to actually create a system that's going to do that.
We know from the Apollo missions that the composition of the regolith, the powdery material that blankets the whole surface of the moon, is composed primarily of silicates.
And we will take in that lunar regolith, separate out all of the constituent materials, and create solar panels and oxygen. If we have oxygen and power on the moon, we open up tons of possibilities.
And if we're going to land a power grid on the south pole of the moon, we want to land that in the location that also has the right concentrations of water so that we can extract that resource and turn it into propellants as well. Because once you do that, you can land and take off from the moon at much lower cost compared to what you can do now.
Our goal is to develop space technologies to go to the moon and establish settlements there. But that technology Although it's being developed for space, we can bring that back to the Earth and we can employ it in mining and manufacturing industries and clean up all the emissions, all the wastewater, all the nasty chemicals and toxic fumes in the cities.
We are just at the beginning. We want to learn on the moon, use it as a springboard to test technologies, to learn how to live off the land. The moon will prepare us and help humanity explore the solar system, not just to go there, but to live there.
Eric, I was so lucky to visit with this team in Southern California and see their solar cells in person. They're not just talking about this technology, they're really demonstrating. They're taking the lunar regolith, breaking it apart into its elements, purifying those elements, and building actual working solar cells. The energy in the lab is palpable.
Absolutely. It's really cool to be able to see us taking advantage of those in situ resource utilization, the resources of space. And this group is focused on how we do that for the benefit of Earth, as well as how we support sustainable missions to the moon with the potential to revolutionize how we produce power and materials on Earth.
Now, while we were learning about our Space Resources program, Mission Control did enter a hold, so we'll pause here and check in on the rocket at the launch pad. Now, Erica, it looks like Mission Control has cleared the hold and the countdown timer is continuing its countdown to our T0 time. We're going to pause here and await Mission Control's go, no-go poll coming up here shortly.
Okay, we've just heard from Mission Control that we are go for launch. Those words really never get old, Eddie. I've been here over 11 years. It's been amazing to watch how our offerings have expanded beyond launch to lunar systems, propulsion, on-orbit destinations, in-space resources.
Yes, things certainly are moving fast here at Blue. We're entering a new chapter, evolving from a research-focused startup to a premier space launch, manufacturing, and services company.
But it really began right here with New Shepard.
That's right.
Demand for our flights only continues to grow. We're scaling the fleet, refining our repeatable processes to meet that growing demand.
And it's just amazing to think that it's still day one.
Always day one, Eddie.
All right, all eyes on the rocket. We're at T-minus 8 minutes until launch. New Shepard is undergoing its final set of checks, and we have some very excited students, scientists, and researchers across the globe right now about to watch their payloads fly in space.
Eagle Cam is on board today. It's a CubeSat camera system developed by students and faculty at Embry-Riddle Aeronautical University. Eagle Cam will test the resiliency of payload components during launch in preparation for a future launch of the Nova-C lunar lander. The prototype will test its ability to withstand loads and shocks and vibrations during the launch, in addition to its ability to calibrate the guidance sensors and determine any camera distortion.
Also on the pad today, Teachers in Space. Now that's the name of a payload, not actual teachers, although we do hope to fly more teachers to space someday. This experiment is collecting data in microgravity and was designed in classrooms in Maine, New Mexico, and Kansas. It provides training and opportunities for teachers and students to learn about spaceflight. Following the flight, they'll collaborate to analyze and present their findings publicly at conferences and science fairs.
Absolutely love watching classrooms do this, Eddie, taking an idea from a hypothesis, building hardware, testing it out, and then coming back and sharing their results.
In terms of collecting data, microgravity's got to be one of the coolest places to do that.
Oh, the ultimate science fair project. Clearly, we've got some great payloads on board today, and we're getting close, a little under 7 minutes until launch. As we're looking at New Shepard on the pad, one new thing I wanted to point out to you today is you'll see on the launch tower that we have added an elevator. Accessibility is really important here at Blue, and the elevator offers us a second way for people to access the top of the tower in addition to the stairs. We added the elevator to make New Shepard more accessible to people with disabilities and more people in general. And this is all part of our broader efforts to build inclusion, make space accessible for more and more and more people.
That's really inspiring to hear, Erica, and thank you. I know you've been a part of this effort from the beginning with the architecture reviews and concept reviews, and recently our business resource group, New Hawking, helped provide some feedback about the elevator and how to make it better. And this is exciting because millions of people living and working in space will mean people of all backgrounds and people of all abilities. So I'm so proud to hear that this is a focus for our team.
And special thanks to our friends at Astro Access who have also been helping us along the way.
And with that, let's review the New Shepard flight profile for today.
7, 6.
New Shepard's mission begins when the countdown clock reaches 0.
2, 1, 0.
At this point, the engine will start and the rocket will lift off of the pad. It will continue under the boost phase for about 2.5 minutes until main engine cutoff. 20 seconds later, the crew capsule will separate from the booster and the astronauts will unharness and enjoy 0G.
Guys, we're doing it!
The crew capsule will continue past the Kármán line to an ultimate apogee of 350,000 feet, or 100 kilometers. The booster will autonomously land on the landing pad, ready to be prepped for its next flight. Around 3.5 minutes after separation, the crew capsule will begin to re-enter Earth's atmosphere. Parachutes will deploy around an altitude of 7,000 feet, or 2,100 meters, providing a nice, slow descent back to Earth. After landing, astronauts exit the capsule and are greeted by the Blue Origin ground crew, family, and friends to celebrate and reflect on their flight. New Shepard, an adventure unlike anything on Earth.
Quite an adventure beyond the Kármán line. These are some of the largest windows to have ever flown in space. More than 1/3 of the crew capsule surface area overlooks that West Texas desert. You get great views of that thin limb of the atmosphere and a great experience for our astronauts. Now, this flight profile that we just heard about is highly tailored to Launch Site 1, to the high elevation, to the safe and flat conditions of the desert. And it's not just for our astronauts, right? That same profile will help our customers, our payload customers, accomplish their mission today and inspire the next generation.
Absolutely. I see that we've entered a hold, so we're going to go watch and listen to New Shepard out there on the pad.
And Eric, I'm noticing that the hold has cleared, that countdown timer resuming its march to T0. What an exciting day for us today. Now, I'm told this is the 9th mission for this booster. Can you tell us a little more about that?
Yeah, absolutely. I think one of the most important things that's been happening in this new era of modern rocketry is that we've learned how to launch, land, and repeat. We've been able to take these boosters and to fly them over and over again. Now, traditional rockets, you'd fly them once, and you'd throw them away. And that was both wasteful and not sustainable. It also turns out that it costs a whole lot more money when you're flying a rocket only once. Imagine flying an airplane and then having to throw it away. We just wouldn't travel very often.
And New Shepard is so special, right? 99% of its dry mass is reused, again, over and over again. So this includes the rocket engines, the parachutes. It's really a paradigm shift from the expendable rockets to the reusable rockets, as you were mentioning.
Yeah, absolutely. And we get to reuse both the capsule and the booster, so that whole stack becoming quite an asset for us as we're plowing our way forward into the future.
Well, thank you for telling us about that. It's very exciting, and just happy to hear that this is the 9th mission.
Okay, we're going to watch and listen as New Shepard goes through its final checks, gearing up for its 24th flight. All right, we have a great view of New Shepard sitting out on the pad, getting ready for launch. Next up in our countdown, we're going to be watching for the bit checks. These are built-in tests to help us make sure that all of our systems are ready to go for flight.
We've got great visuals here of New Shepard on the pad. We'll get great audio as well through those built-in tests. And as we see them, we'll call them out.
Yeah, Eddie, the first thing we're going to be looking for is the aft fin checks. So if you look down there at the base of the booster, you can see those fins, those control surfaces that rotate to help direct the vehicle on ascent and descent.
A little bit like sticking your hand out the window while your car is driving. The air pushes against the aerodynamic surface, helping to control the vehicle.
There we go. We see the gantry pulling back. Now the booster is getting ready. We are used to seeing the gantry out there so we can do load-in of our astronauts, our payloads. Again, no humans on board today, but everything ready to go. We're watching for those aft fin checks. You'll watch them rotate at the base of the vehicle.
And there they go, moving through the full envelope of motion there. Great built-in test.
After those aft fins, we're going to be looking for the engine nozzle gimbaling. The engine gimbals or rotates to help maneuver the rocket as it flies, providing a thrust vector control. Meanwhile, we're keeping an eye on the pressure and temperature in the propellant tanks. Both of those sets of variables need to stay in the start box or the green zone for us to be ready to launch. Okay, we are at T-minus 30 seconds. It is time to hand it off to mission control. Let's launch this rocket.
Minus 16, guidance internal. 10, 9, 8, 7, 6, 5, 4. Command engine start. 2, 1, 0. Ignition.
We
There
have
we see-
ignition of our BE-3 engine. And liftoff. Mission Control confirms that New Shepard has cleared the tower and is headed to space. You can see on the lower left side of your screen that we're gaining speed. As New Shepard gains altitude, the atmosphere gets thinner. The graph on the left shows vehicle ascent. Now, we actually started at about 3,700 feet MSL. That's how far above mean sea level we are at Launch Site 1.
How exciting, Erica. A great shot there of the PM, the propulsion module, moving away from Earth. That BE-3 engine providing 100% power level. And here shortly, we will approach max Q. This again is the point where aerodynamic stress on the vehicle is at its maximum. So the BE-3 engine will throttle back for a little bit as we pierce through the atmosphere. Now that we've passed max Q, BE-3 will begin to throttle back up to 100% power level. We'll see that velocity ticker on the left of your screen start to increase more rapidly as the air gets thinner. New Shepard is moving faster and faster.
Absolutely. You can also see that engine plume start to expand as we get into that thinner, high upper atmosphere. Such a cool shot there.
So just over 2 minutes of boost for the BE-3 engine before we reach the next stage of our mission, MECO, main engine cutoff. That will be the next milestone we'll see.
New Shepard continues to climb 145,000 feet.
There it is, main engine cutoff, just over 2,200 miles per hour, and soon vehicle separation.
Always love seeing us coast through MECO. Now, when the vehicles separate and the crew capsule from the booster, we're going to be entering that phase of microgravity. And you can see that zero-G indicator at the bottom of your screen. This is really where most of our payloads are getting into the core of their science mission. Oh, what a fantastic view.
All sorts of cool experiments here enabled in microgravity, in free fall. Items don't sink or float. Hot air doesn't rise. Plants and cells respond to this novel stimulus with different patterns of gene expression, which gives us new insights for agricultural technologies and medicine.
And we talked earlier about the importance of fluid physics, because fluid flow on the ground dominated by gravity, the liquid at the bottom of your cup. But in space, it's dominated by surface tension, which leads to all sorts of cool effects with capillary action. And these effects are relevant for everything from drinking coffee to refueling satellites to the microfluidics in your medical diagnostics.
Incredible, and I'm sure the payloads are enjoying all of the clean, very clean microgravity data that they're collecting at this time.
And loving that view back down on the clouds over West Texas. Now, if you watch that ticker on the lower left corner, you see we are slowly counting down in our velocity to 0. That's the vertical velocity of the system. And when we reach 0, that's when we've reached apogee. And fantastic. Capsule pausing in its upward journey just momentarily. Apogee for the capsule at 351,247 feet, well into space and over the Kármán line. Fantastic mission for our payloads on board today.
And Erica, so now we've got both vehicles racing back down to Earth under the effect of gravity. The gumdrop shape here of the crew capsule will mean a slower return for the crew capsule, but there on the left, a great view of the propulsion module returning back to the West Texas desert.
So as we come back down and the atmosphere begins to get thicker again, we start to have the ability to use our aerodynamic control surfaces. What you'll be seeing next is the air brakes deploying. This is a critical step in slowing the vehicle down, increasing the surface area, just like a badminton shuttlecock or something that's helping you to come down through the upper atmosphere. We're going to see that the velocity starts to decrease with those air brakes out.
In fact, the drag brakes should cut the velocity in about half. So we'll be looking for that, picking up, hopefully with the cameras, the long-range cameras, and seeing those drag brakes deploy as the propulsion module cuts through the atmosphere. And those are the forward fins deploying there on the right, a great view looking up from the propulsion module into space and seeing those forward fins deploying.
You can see the capsule passing by just there on the right-hand screen, well above the booster at this altitude.
What a great video shot. I love seeing this. Those are our experiments, our customers today getting their microgravity data in.
So that booster coming in at about Mach 3, pulling at about 5 Gs as it re-enters the atmosphere. So we're going to be seeing that velocity decrease rapidly at this point.
And this is one of my favorite parts of observing a mission from West Texas. Those are the drag brakes. There they are deployed. And we see those aft fins steering the booster over the landing pad.
Yeah, if you're in West Texas, you may be hearing a sonic boom coming up here as we break through the sound barrier.
BE-3 engine relight, just 2,000 feet to go before the landing pad.
Landing gear deploying. Oh, love that shot. I can't tell you how many people have told us they thought that this looks like CGI, but indeed one of these most beautiful shots in the West Texas desert. And we have booster touchdown.
Congratulations, New Shepard propulsion module and the BE-3 engine for providing just the right feathered thrust to come in for the nice hovering land.
And again, that's the 9th flight for this booster, really showing the operational reusability of this system and how many times we can get back to space.
Well, Erica, we've just safely landed the booster. Now we're about to watch the crew capsule make its final descent back to the West Texas desert. In parallel, the team will vent the propellants, any remaining propellants, from the propulsion module and begin safe recovery operations so that we can prepare it for its next mission. Well, these shots are incredible. We've got the Sierra Diablo Mountains in the background, some yuccas and some choyas, and of course, a world-class propulsion module booster on a landing pad. This is awesome.
Yeah, it's a pleasantly toasty marshmallow having come right back from space. I absolutely love being out in the desert and just standing next to a rocket that just that morning flew up to space and back. Absolutely amazing.
And the thermal protection system, oh, there we go. We've got main parachutes, 3 main parachutes on the crew capsule as it makes its descent back from space to Earth.
Those parachutes reefed when they're first let out and then expanding to their full diameter. Now, the parachutes are essential in providing a gentle touchdown for the crew capsule, but we also have a retro thrust system on the bottom of the capsule that makes that landing even smoother. So as we're coming down, nice slow velocity right around 1,600 feet, we're going to be looking for that retro thrust system as we get closer to the desert floor.
And Erica, this retro thrust system is effectively high pressure gas that is fired off to make a cushion of air, soft landing for the crew capsule, but it kicks up some dust.
Such gorgeous scenery, such a gorgeous crew capsule, and again, those parachutes doing their job, taking us down to just about 15 miles per hour. The retro thrust system will take us down to just 1 or 2 miles an hour as we get down to the base of the desert floor.
There it is, touchdown for NS-24 and our 33 customers and 38,000 postcards.
Closer than you think. It's your time to join the new generation of astronauts. To book your flight, visit BlueOrigin.com and click Fly to Space. Tell us as much as you can about yourself. We welcome you to the final frontier.